Hello, and welcome to the JMA webinar on NWAV RET system. My name is Vuth Ith with JMA Tech Support. This webinar has three main objectives. The first is for you to gain knowledge on basic RET systems. Second, we want you to become familiar with the NWAV RET antennas. And third, we want you to get a better understanding of the testing and troubleshooting of the NWAV RETs. Webinar content. This is a list of the contents that will be discussed during this webinar. RET system diagrams will show you some examples of how the RRU is integrated with the RET antenna. NWAV antenna label and NWAV RET diagrams will give you a better understanding of our NWAV antenna product. Ground testing and commissioning, as well as troubleshooting, will cover some test diagrams so that you know how to do the testing and go over some basic troubleshooting and solutions. And last, JMA website and support. We'll give you information on how to contact JMA when you need support. RET system diagrams. Before we get into the details of the diagrams, I would like to quickly discuss Smart BIASTs, shown here as SBT for short. Smart BIASTs are used to inject and extract DC and AISG signal between the RETs and the radio. For this diagram, we will refer to ground-based radios as E node B and RRU for top-mounted radios. RET system example 1. The E node B will send the DC and AISG signal through the internal Smart BIAST up the feeder to the top-mounted Smart BIAST. The Smart BIAST up top will be used to extract the DC and AISG signal through the AISG cable that is connected to the RETs. Each of the RET on the antenna, as well as from antenna to antenna, will be daisy chained according to the RFDS. RET system example 2. The RRU is mounted up top, and the RET port on the RRU will have an AISG cable connected between the RRU to the RET. That's how the DC and AISG signal is being sent to the RETs. Again, follow the RFDS for daisy chaining. RET system example 3. Again, the RRU is mounted up top, but instead of using the AISG cable to send the DC and AISG signal to the RETs, the radio has an internal Smart BIAST built in that will be used to send the DC and AISG signal to the RETs through the RF coax. Our NWAV antenna has internal Smart BIAST built in that will extract the DC and AISG signal and feed them to the RETs internal to the antenna. NWAV antenna label. Antenna serial number and antenna model number are shown at the top, and the antenna information regarding band of operation and port number, as well as the RET information showing the tilt ranges and the RET unique IDs are also provided on the label. Keeping good records of the antenna label is critical to identify where each of the antennas are mounted per position and sector. The RET information and the unique IDs are also important to have during the commissioning so that each RET can be labeled properly per sector and position. Remember to not remove the factory installed brackets that are on the antenna. NWAV antenna nomenclature. This document is available on our website for download. Let's break down this example model number to get a better understanding. The MX identifies the product series and the polarization type. So M for macro and X for cross pole. 08 identifies the number of ports on the antenna, 8 ports or octoport. FRO is the product feature for fast roll-off. 6 is the height of the antenna in feet, so 6-foot antenna. 60 identifies the horizontal beam width, which is 60 degrees. And the -02 gives us the product variant. 02 down here identifies the antenna having RETs and smart BIASTs. NWAV is the product series for our Generation 2 antennas. The NWAV antennas will have ports mounted on the bottom, and the RETs will be internal to the antenna. This table gives you a summary of the tilt ranges for the low band and the high band RETs. All of the high band RETs will have a 0 to 9 degrees regardless of the height. The 4-foot antenna will have a 2 to 16 degrees tilt range for the low band RET, 2 to 14 degrees on the 6-foot, and 2 to 12 degrees on the 8-foot for the low band RETs. NWAV RET and connector topology. This diagram is available as part of the spec sheet and can be downloaded from our website. Each of the ports, RF and AISG on this diagram, is color-coded per AISG standards. We have red for the low band and blue for the high band. On the hex port antenna, it consists of 1 low band and 2 high band antennas. There are 2 RETs on the hex port antenna. You have RET device 1 for the low band and RET device 2 for the high band. Also note the frequency of operation for each of the bands and the port number assignment. The octoport antenna consists of 2 low bands and 2 high band antenna. There are 3 RET devices on the octoport antenna. You have 2 here for the low band and 1 for the high band. Each of the low band has a RET, 1 for the 700 antenna and 1 for the 850 antenna. On the high band, 1 RET will control both of the high band antennas. There are 2 sets of DC and AISG bus on each of the antennas. There's a low band set shown here and a high band set shown here. On the hex port antenna, RF port 1 and RF port 3 has the internal smart BIASTs. On the octoport, it's RF port 1 and RF port 5 that has the internal smart BIASTs. It is very important to remember that only 1 DC and AISG connection per path is allowed. Also note that the DC and AISG bus on each antenna are not internally tied between the low band and the high band sets. They are individual, so if you need to daisy chain, you must tie them together. RRU-RET connection diagram example. This diagram shows you 2 NWAV antennas that are integrated to the RRUs for RET controlling through the RF port. On antenna 1, the 700 RRU will be controlling the RETs through the RF port that has the internal smart BIAST. RF port 1 will extract the DC and AISG signal from the radio and pass it on to the internal RETs. The low band RETs on antenna 1 is daisy chained with an AISG cable to the low band RETs on antenna 2. So both set of low band RETs on antenna 1 and antenna 2 will be controlled by the 700 RRU. For the high band RETs on each antenna, antenna 1, the AWS RRU is connected to RF port 5, which has the internal smart BIAST, and on antenna 2, the PCS RRU is also connected to RF port 5. Each RET on the high band of antenna 1 and on antenna 2 are controlled individually by each radio. Antenna 1 with the AWS RRU and antenna 2 with the PCS RRU. RET controller test diagram 1. This test diagram shows you how to test the RET antenna through the RF port. Through the use of a bottom smart BIAST, the JMA RET controller can inject the DC and AISG signal to the RF port that has the DC and AISG bus. On this octo-port antenna, RF port 1 and RF port 5 can be connected to do the testing. BIAST and AISG pin connections. Here we have an example of a test kit using a JMA bottom smart BIAST with a short jumper that is made with 1/4 inch superflex coax, having a DIN male connector on one end that's connected to the smart BIAST and a 4310 male connector to connect to the antenna. And here's the example of how the smart BIAST is connected to the antenna for testing. We also have the AISG pinouts provided for you for troubleshooting so that you can use a voltmeter to measure pins 6 and 7 for DC voltage coming out of the RET controller. RET controller test diagram 2. This is a very simple test diagram that shows the JMA RET controller connecting to the AISG bus on the antenna to test the RETs. Remember that there can only be one DC and AISG source going to the bus. If you run into any conflicts, ensure that the radio connected to RF port 1 and RF port 5 is disabled or disconnect those RF jumpers to isolate. Ground testing and commissioning. Start by recording the antenna label information. Remember the importance of the items on the label and keep good records for your closeout package. Connect RET controller for testing. Commission the RETs according to the RRU connection diagram. Refer to test diagram 1 or 2. We strongly recommend that if the RRU will control the RETs through the RF port, follow test diagram 1 that incorporates the bottom smart BIAST for testing. If daisy chaining is required, follow the RRU connection diagram and make sure to test all the RET cables that are used for daisy chaining to verify there are no issues. We also have available a detailed map on the RET controller and GUI operations on our website. RET testing and configuration. Once the RET controller is connected to the RETs for testing, scan the bus to locate and find all the RETs on the antenna. Verify the antenna model matches the antenna label. Calibrate each RETs. Once the RETs are calibrated, set the tilt for the RFDS. Don't forget to enter the operator configuration to label the RETs per the installation date, installer ID, site ID, etc. The JMA GUI also has a feature that you can save a RET report. A RET report can be generated that will capture all the pertinent information on the RETs that you could provide as your closeout package. Very important note to remember during the installation. Do not forget to use the supplied tube of dielectric grease on the AISG connectors. The dielectric grease is used to prevent water ingress and to prevent corrosion and oxidization on the connection. Sample RET report. Here's a sample of the RET report that's generated by the JMA GUI. The RET type is provided here. All of the JMA RETs are single RETs. Single RETs are classified as type 1. Also, on the NWAV antenna, the RETs are internally mounted and they're not field replaceable. The RET serial number information as well as the software and hardware information is provided here. Remember that the unique ID is a combination of the serial number, which has 17 characters, and the vendor code Charlie Charlie for CSS. So if you add Charlie Charlie to the serial number, you'll end up with a unique ID of 19 characters. Antenna model number and serial number can be verified here. The tilt ranges are provided here. Verify the tilt setting is set according to the RFDS, and also verify that the operator information is correctly entered. Incorrect connection, example 1. If you haven't already noticed, throughout this webinar, we've been stressing the importance of not having multiple DC and AISG connection on the RET bus. This connection diagram example shows you a scenario where ground testing or commissioning of the RETs was not performed prior to the installation of the antenna and the RRU integration. The 700 RRU is already integrated with an RF jumper to antenna port 1 of antenna 1. If you're called on site to go and test the RETs, and you're going to connect your RET controller to the AISG bus on antenna 1 and then daisy chain to antenna 2, there's going to be a conflict with the 700 RRU. The incorrect connection here is the RF connection of the RRU to the RF port. You must contact the switch to have the 700 RRU disabled and disconnect this RF jumper to ensure there's no multiple DC and AISG coming in at the same time as the RET controller. Incorrect connection, example 2. Again, if the antenna is already installed and the RRU integrated, you might run into this issue. If the low band RETs on antenna 1 is daisy chained to the low band RETs on antenna 2, and that is daisy chained to the high band RETs on antenna 2, there could be a conflict. When you connect the RET controller using a bottom smart bias T to inject the DC and AISG on RF port 1 of antenna 1, you could run into a conflict if the AWS RRU is enabled and sending DC and AISG to antenna 2 on RF port 5. To correct this test diagram, either the RRU needs to be disabled and this RF jumper removed, or the the daisy chain cable here of low band RET to high band RET needs to be disconnected. Troubleshooting with the RET controller. If you cannot discover the RETs with the RET controller, ensure that the RET controller is the only DC and AISG source to the RET bus. Follow incorrect test diagram 1 and incorrect test diagram 2 to ensure that there are no multiple DC AISG bus connection. Also verify the COM setting is working properly. The JMA RET controller will have the LED flashing red and green if the COM has been set up properly during the scan. If it's not alternating red and green, that means that the COM setting has not been properly established. If using a Smart Bias T to connect to the RF port on the antenna for testing, verify that the Smart Bias T connection is done correctly. Follow test diagram 1. Also, for E-Node B connections that are ground-based radios, if there are multiple ALDs in line, such as diplexers and triplexers, make sure that the DC pass-through is working properly according to the logic table. If you are still having issues, bypass the ALDs in line and go directly to the antenna up top by sending the Smart Bias T, the bottom Smart Bias T, up to the top and using a home run cable to connect directly to the RETs on the antenna, bypassing all of the ALDs. You can also check pin 6 and 7 on the AISG connection to verify that the DC voltage from the RET controller is making its way to the motor. The JMA RET controller outputs 24 volts DC. you can refer to the pinout diagrams of the AISG cable that's been provided earlier with the Smart BIAST example. You can try to verify the DC voltage on pin 6 and 7 starting with the AISG port on the antenna and work your way down all the way back to the RET controller. Troubleshooting with the RET controller continued. If you're getting a RET actuator jam during calibration, try calibrating several times. Sometimes there's interference on the RET bus and the command may not be given correctly, or the calibration may time out. You can also try resetting the bus and recalibrating. If you're still experiencing a jam during calibration, contact JMA Tech Support for help. If your RET is jamming during tilt adjustment, first of all, verify that you calibrated the RET first before trying to set the tilt. If the RET is not calibrated, it will not know how to step. Second, you could also try resetting the bus again and repeat the tilt setting. If you're still getting a jam, contact JMA Tech Support for help. Troubleshooting, RRU-RET control. Once the RETs are integrated to the RRU for controlling, if the RRU cannot discover the RETs, first verify the plumbing diagram with the system performance engineer. Verify how the RRU is supposed to control the RETs, but based on the assignment, either through the RF port or the AISG port, and make sure that the scripts match that control assignment. You can also verify if the RRU is outputting DC to the RET bus. Check pin 6 and 7 on the AISG port of the antenna. If still not successful, you could use a RET controller to verify the RET functionality through the same path. So if the RRU is controlling the RETs through the RF port on the antenna, use a bottom Smart BIAST to hook up to those RF ports with the RET controller, making sure the radio has been removed out of the path. If the RET controller verifies the RETs to be performing good and there are still issues, contact JMA Tech Support regarding HDLC log capture. You could renormalize the site according to how the RRU is connected, and we can try to capture the HDLC log to see the traffic between the radio, if there's any, to the RETs. If the RRU can discover the RETs but can't calibrate or set tilt, you can repeat the steps by using the RET controller to verify the RETs through the same path connection. If the RETs are functional with the RET controller, check with the SPE if the RRU firmware is current. Ask the SPE to compare to other sites having the same equipment and configuration to try to compare apples to apples to see where the mistake may have been made. Ask the SPE to also work with the RRU OEM if there's still issues. And again, you could contact JMA Tech Support regarding HDLC log capture so that we can verify if there's traffic coming out of the radios to the RETs. JMA website and support. This slide gives you the information on how to contact JMA for support. During normal business hours, we are available from 8 a.m. to 5 p.m. Eastern Time. After hours, we'll go through our call center and the on-call person will be alerted of the issues to contact you. You can reach us with the 888 number at 1-888-201-6073. You can also contact us via email. Our email address is techsupport@jmawireless.com. If you have purchasing and lead time questions on our products, you can contact customer service at customerservice@jmawireless.com. This is the address to the JMA Wireless homepage. On our homepage, we have an available search box where you could enter your search requirements to get information on our products. You could also click on the support tab here on the main page and you'll get additional information on the various products that we have available. The antenna system section is shown here. The fixed and RET product matrix can be found here by clicking on this active link. You'll get a list of the antenna models that you can click on to get the spec sheets. The RET mop for our RET controller and GUI operation can be found here, and additional information on our legacy RETs, the external RETs, can be found here. Thank you for taking the time to watch this webinar. We hope that the information provided will be useful for your application. Thank you.